NASA's Juno probe. How heating up a broken camera saved Jupiter's closest looks. In a jaw-dropping display of interstellar ingenuity, NASA repeatedly resurrected a dying camera on its Jupiter probe by essentially baking it in the vacuum of space, proving that sometimes the simplest solutions defy cosmic odds. The JunoCam, mounted on the Juno spacecraft orbiting Jupiter, started failing under the gas giant's brutal radiation, which is so intense it systematically fries electronics. But here's where it gets controversial. NASA's thermal revival technique pushed the camera beyond its planned limits, gambling with irreplaceable equipment 370 million miles away. When initial glitches appeared, engineers warmed the camera to a mild 25 degrees Celsius, like giving it a spa day. But just before a historic close flyby of Jupiter's volcanic moon Io, image quality deteriorated again with streaks and noise. In a high-stakes move, NASA maxed out the heating systems. Days later, the camera snapped back to life with dramatically improved clarity, capturing Io in unprecedented detail. This annealing process, borrowed from materials science, involves heating components to repair radiation-induced defects, much like reheating chocolate to fix imperfections. And this is the part most people miss. The success was so transformative that NASA retrofitted the technique across other Juno instruments and subsystems, creating an unexpected blueprint for future deep space missions. Despite completing 74 orbits in Jupiter's lethal radiation belts, far exceeding its original 8-orbit lifespan, recent images show noise returning. While it's unclear if NASA will heat the camera again, mission lead Scott Bolton confirms these ad hoc repairs generated priceless knowledge applicable to military satellites, commercial spacecraft, and upcoming NASA projects. Launched 9 years ago, Juno's endurance enabled groundbreaking discoveries. Jupiter's magnetic field is wildly stronger than predicted. Its north and south poles differ bizarrely, previously unseen territory, and it revolutionized our understanding of Io's volcanoes. With the mission extended to September 2025, one burning question remains. Should we keep risking fragile hardware in extreme environments when repairs require cosmic-scale improvisation? Or does this ingenuity justify pushing boundaries? What's your take? Calculated brilliance or reckless gamble? NASA's daring JunoCam save. How scientists fixed a camera 370 million miles from Jupiter. Imagine fixing a camera 370 million miles away, near Jupiter. That's exactly what NASA achieved with an innovative technique that could revolutionize space missions. This remarkable feat not only saved the Juno spacecraft's JunoCam imager, but also provided invaluable insights for future space systems facing high radiation challenges. In December 2023, the Juno mission team executed a daring deep space maneuver to repair JunoCam, enabling it to capture stunning photos of Jupiter's moon Io. The results of this long-distance rescue were unveiled on July 16 at the Institute of Electrical and Electronics Engineers' Nuclear and Space Radiation Effects Conference in Nashville. JunoCam, a color-visible light camera, is positioned outside a protective titanium-walled radiation vault, safeguarding the sensitive electronics of Juno's instruments. However, this location poses a significant challenge due to Juno's passage through the most intense planetary radiation fields in our solar system. While mission planners were optimistic about JunoCam's durability through the first 8 Jupiter orbits, its long-term viability remained uncertain. Remarkably, JunoCam functioned flawlessly during the first 34 orbits, contributing essential images to the mission's scientific research. But during the 47th orbit, signs of radiation damage emerged. By the 56th orbit, almost all images were unusable. Diagnosing the issue from such a vast distance was daunting. The team suspected a damaged voltage regulator crucial to JunoCam's power supply. With limited options, they turned to a process called annealing, involving heating a material for a specific duration before gradual cooling. Although the mechanism isn't fully understood, the hope was that heating would mitigate material defects. We weren't sure if annealing would fix the damage at a microscopic level, but we had to try, explained Jacob Schaffner, JunoCam imaging engineer at Malin Space Science Systems in San Diego. We increased JunoCam's temperature to 77 degrees Fahrenheit and waited anxiously for the outcome. To their relief, JunoCam resumed producing clear images for several orbits post-annealing. However, as Juno delved deeper into Jupiter's radiation belts, the images deteriorated again by the 55th orbit. "Our images were riddled with streaks and noise," said Michael Ravine, JunoCam instrument lead. "Despite various processing attempts, nothing improved the quality. With Io's close approach looming, we decided to crank up JunoCam's heater to its maximum, hoping more intense annealing would work." Initially, the test images showed minimal improvement. But as Io drew nearer, the images began to sharpen significantly. By December 30, 2023, when Juno was just 930 miles from Io's surface, the images were nearly as pristine as at launch, revealing detailed views of Io's North Polar region, including sulfur dioxide frosted mountains and previously uncharted volcanoes with extensive lava flows. To date, the solar-powered Juno has completed 74 Jupiter orbits. Recently, image noise reappeared during the 74th orbit. The Juno team has since applied variations of the annealing technique to other Juno instruments and subsystems. Juno is a pioneer in radiation-tolerant spacecraft design, offering lessons that will enhance Earth-orbiting satellites and future NASA missions, said Scott Bolton, Juno's principal investigator from the Southwest Research Institute in San Antonio. Managed by NASA's Jet Propulsion Laboratory in Pasadena, California, Juno is part of the New Frontiers program, overseen by NASA's Marshall Space Flight Center in Huntsville, Alabama. The Italian space agency funded the Jovian infrared auroral mapper, while Lockheed Martin Space in Denver built and operates the spacecraft. Numerous U.S. institutions contributed additional scientific instruments. For more on Juno, visit https://www.nasa.gov/Juno. DC Jet Propulsion Laboratory, Pasadena, California. 818-393-9011. Eagle@jpl.nasa.gov. Karen Fox/Molly Wasser. NASA Headquarters, Washington. 202-358-1600. Karen.c.fox@nasa.gov/molly.l.wasser@nasa.gov. Deb Schmidt. Southwest Research Institute. NASA's Juno camera saved from Jupiter radiation using Hail Mary fix. Imagine a camera clinging to life 370 million miles away, battered by Jupiter's radiation, a force so brutal it could fry electronics in seconds. This was the desperate reality for NASA's JunoCam in late 2023, and its survival hinged on a gamble reminiscent of a cosmic Hail Mary. Launched in 2011 to unravel Jupiter's secrets, the Juno spacecraft ventured into the solar system's most hostile radiation zone. JunoCam, its color camera, was never designed to last forever. Scientists predicted it would survive only 8 orbits. But by orbit 47, the first signs of radiation damage appeared: streaks, noise, and a failing voltage regulator critical to its power supply. With Io's volcanic landscapes looming as a final photo opportunity, the team turned to annealing, a process of heating silicon to heal microscopic defects, akin to baking a fragile material back to health. We heated JunoCam to 77 degrees Fahrenheit, warmer than its operational norm, and waited, explained Jacob Schaffner, a JunoCam engineer. The results were astonishing. Clear images of Io's unseen volcanoes on December 30, 2023, including a mountainous lava lake. But here's the controversy. Was this temporary fix a triumph or a band-aid? The camera failed again by orbit 74, sparking debate. Are such repairs sustainable for deep space missions, or do they mask flaws in design? Juno's lessons will arm future satellites against radiation, noted principal investigator Scott Bolton. But at what cost to durability? As scientists present these findings, a question lingers. In the race to explore, contemporary miracles like JunoCam's annealing trick justify the risks of under-armored tech? Share your thoughts. Should space agencies prioritize resilience over quick fixes?